Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 2,2-dimethylhexane, 1-ol, a primary neopentyl type alcohol where the carbon bearing of C1 is primary and the adjacent carbon C2 bears two methyl groups and a butyl chain. Moving on to the next step. The OR is protonated to give a good leaving group, water. Direct ionization of a primary carbocation is highly unfavorable. Instead, the system undergoes a 1,2-hydride or 1,2-alkyl hydride shift simultaneously with or after ionization. The primary C1 loses water to transiently form a primary carbocation at C1 which immediately undergoes a 1,2-hydride shift from C2 to C1 generating a tertiary carbocation at C2 which bears two methyl groups and the N-butyl chain. This tertiary carbocation at C2 is much more stable. Moving on to the next step. Elimination, E1. From the tertiary carbocation at C2, the carbocation at C2 can lose a proton from an adjacent carbon. The adjacent carbons are C1, now CH2 after hydride shift, i.e. is equal to CH2 formation, or C3, the CH2 of the butyl chain. Loss of a proton from C1 gives CH3, CH2, 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 CH is equal to C, CH3, 2, which is a trisubstituted, more substituted, alkene. Loss of a proton from C3 gives CH3, CH2, CH2, CH is equal to C, CH3, dash. A different product. By Zaitsev's rule, the more substituted alkene is the major product. And for the final step, loss of H plus from C1, the CH2 originally bearing O, now is equal to CH2, gives CH3 CH2 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 CH is equal to C, CH3, 2, which is option B. This is a trisubstituted alkene and represents the Zaitsev, more substituted, more stable product. Option A would require a different carbon skeleton rearrangement not consistent with a simple 1,2-hydride shift followed by E1. Option C, CH3, CH2, 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 C, CH3 is equal to CH2 is a less substituted, terminal, alkene. This would be the minor product, anti-Zaitsev. Option D involves a skeletal rearrangement of the butyl chain, methyl shift, leading to a branched product, which is less favorable than the straightforward 1,2-hydride shift giving the tertiary carbocation followed by Zaitsev elimination. Therefore, the correct answer is B. Therefore, the correct answer is option B.